Hi, hi, hi. Good morning, good morning. Good morning, good morning, good morning. No one is saying anything. Good morning, good morning. People slept. Good morning, good morning, good morning, good morning. Yeah, good morning. Good morning, good morning, good morning, good morning. Bagunara, Bagunara, Bagunara. Good morning, good morning. Yeah, Bagunara. Yeah, okay, very good, very good, very good. So what's going at home? घर पे क्या हो रहा है? What's going on? Chilling or studying? What's going on? Studying, sir. Studying, sir. Yeah. Okay. If you are chilling, sir, then chilling with studying. If anyone asks you what going on, say chilling. After that, say with studying. Yeah. Okay. No problem. No problem. Yeah. We are knowing, sir, we have to work hard. We have to become doctor next year. So that's why we have to work hard. That's why we are studying, sir. That's why we are chilling. That's why we are chilling. But that chilling is chilling with studying. Yeah. Is it okay? Is it correct? Is it correct? You are chilling, but you are chilling with studying now? You're chilling only. Yeah. But sir, we are chilling with studying. Yeah. Kids chill with movies and everything. We are ultra pro legend. Yeah. And we are, that's why we are chilling with studying. Yeah. Okay. No problem. No problem. Yeah. Okay. Okay. Very good. Yeah. So, okay. No chilling, sir. Only studying. Are study is also type of chilling only, Baba. Kab samjhoge? Studying is also a type of chilling. Yeah. Okay. No problem. No problem. Yeah. So shall we start with the class? शुरू करें क्या? Shall we start with the class? Yeah, okay. We enjoy with study, sir. Nayak, very good. Good attitude. Yeah. Sir, study is also a type of enjoyment. Yeah, okay, no problem. Yeah. And I think in last class we studied about maximum and minimum value of resultant now. What can be maximum limit of resultant? What can be minimum limit of resultant? Yeah. So maximum was coming a plus b when angle was 0 degree. Minimum was coming a minus b when angle was 180 degree. Is it okay? Is it okay? Is it okay? Yeah, okay, very good, very good. Yeah. Syllabus I will tell yoga, don't worry. Don't worry. Yoga is worried asking, sir, what is the syllabus of Sunday exam? Or, wait, Baba. I will tell, yeah. So assignment did not come to you. In the app, did you checked? In the study material in the app, did you checked? Did you check in the app? Not came. I asked. Okay. Physics not came. Only chemistry came. Geology they put. Okay, I will ask now. Just after the class, I will ask. I will just finish out that. Then only I will go to home. Before Bhojanam, assignment will be put in the group. Don't worry. Yeah. Okay. Okay. No problem. No problem. Huh. So let's start. So we're talking about all those things: resultant, maximum, minimum, a plus b, maximum, minimum, a minus b. Now today we'll move further and we will talk about one more part. We'll talk about components of vector. Components of vector. You can do last year. Neha, you can do, no problem. You can do last year material, no problem. That's good. That's the best material. Yeah. Okay. So now we'll start with next part. We'll talk about component of vector. You can write component of vector. We'll talk about components of a vector. So how many components a vector has? How many components a vector has? You have studied. How many components a vector has? Yoga is saying 2, 21, 21 is also saying 2. Many people are saying 2. Neha is also saying 2. Trishal is also saying 2. Trishal is saying 3. All these are wrong. All these answers are wrong. There is one point here. There is one point here which people don't know. Yeah, infinite is the correct answer. Yeah. Avinay, yeah, correct. Priyanka, correct. Okay, we'll talk about slowly. Okay, no problem. So you can write topic name, components of a vector. Components of a vector. Components of a vector. I've just written components. You'll write the complete name of topic. Components of a vector. Yeah. So always remember there are some theoretical points which are asked from here. Then we will move towards our numerical part also. Always remember, if anyone asks you how many components a vector can be broken, always remember you can always break a vector into everyone knows meaning of component. Component means breaking the vector. Component means you can break a vector. The way we say now, we can break a biryani. If you have biryani, you can divide biryani into different parts. One part will be rice, one part will be spices, one part will be the chicken. In biryani, you cannot forget chicken, sir. Yeah. So in the same manner, we can split a vector into different parts. Those parts are known as component of vector, but no need to write. You are not junior student that you write what is meaning of component. Okay, no problem. Yeah. So point is, always remember, if anyone asks you what is the maximum number of components in which a vector can be broken, answer will be infinite. You can break a given vector into infinite number of components. Without any doubt, you can break a vector into infinite number of components. Then you will think, sir, then what we studied, sir, a cos theta, a sin theta, two component we studied. What are those then? You are saying infinite component. We studied only two component. Can you tell me what are those? They are a special type of component. They are known as rectangular component. They are known as rectangular component. People were saying answer 2 and 3. They are talking about a special. If anyone asks you how many rectangular component a vector can be broken in 2D, then answer will come 2. How many components a vector can be broken in 3D? In space, how many components? Answer will come 3. So always remember, you can write these points, theoretical points. Sometime, somewhere question may be asked. So you can write this. You can write this. Yeah. You can write. We can break a vector into infinite number of components. We can break a vector into infinite number of components. We can break a vector into infinite number of components. This is the first point. We can break a vector into infinite number of components. Now write the second point. Write the second point. a vector will have two rectangular components in 2D. This is the meaning of 2D. A vector will have two rectangles. Now you see, I'm not talking about component, I'm talking about special component. Yeah. A vector will have two rectangular components in 2D. What is meaning of 2D? What is meaning of 2D? Don't say the full form, two-dimensional. What is the meaning of 2D? What is the meaning of 2D? A vector will have two rectangular components in 2D. 2D means plane. 2D means plane. 2D means plane. 3D means space. So in bracket you write a vector will have two rectangular components in 2D bracket plane. Bracket plane. And three rectangular components in 3D. And three rectangular components in 3D. And three rectangular components in 3D. What is the meaning of 3D? What is the meaning of 3D? What is the meaning of 3D? Space. So in bracket you can write space. In bracket you can write space. So always remember, maximum number of components in which a vector can be broken will be infinite. But in physics, we don't talk about those infinite components. In physics, we talk about special type of component. Those special components are known as rectangular components. In 2D, those rectangular components will be 2. In 3D, those rectangular components will be 3. Is it okay for everyone? Is it okay for everyone? Is it okay for everyone? But now you will be thinking, sir, then what is meaning of rectangle? You said everything, how many rectangular component in 2D, special component, but what is the meaning of rectangular component? Can you tell me what is rectangular component? What is rectangular component? What is the meaning of rectangular component? Special, now what is that special rectangular component? Which components will be known as special components? Which components will be known as rectangular component? Bolo, jaldi. Understand what is meaning of rectangular component. First thing, you tell me what is the angle between the two sides of a rectangle? What is the angle between the two sides of the rectangle? What is the angle between the two sides of rectangle? 90 degrees. So always remember, when your components are perpendicular now, yeah, components, when you break a vector and the two components of the vector are perpendicular, then those perpendicular components are known as rectangular component. Why name rectangular? Because in rectangle, two sides will be having 90 degree. That's why they are known as rectangular component. For example, if this is a vector, if you break this vector, you see this, my whole, both combined palm is a vector. If you break into two parts, and if both parts are perpendicular to each other, these two parts will be known as rectangular component. Are you getting the idea? You can write this also. Perpendicular components of a vector are known as rectangular components. Perpendicular components of a vector are known as rectangular components. Perpendicular components of a vector are known as rectangular components. So before moving further, I will just ask you few things. Then we will start rectangular components in 2D. Okay, no problem. First thing, you tell me into how many components a vector can be broken maximum. Maximum, how many component a vector can be broken? Infinite. Any number you want, you can break, sir. For example, this pen is like a vector now. Vector means arrow now. Vector means what? Vector means arrow now. So if you look at this pen is an arrow. This is a vector. You can break this pen into two parts. You can break into three parts. You can break into 10 parts. Or take a hammer, make it in small pieces. It will become infinite parts. So we can break a vector into infinite number. But you tell me, in physics, does we talk about these components? Does in physics we talk about these components? No, in physics we always talk about special component. One in the direction of motion, one perpendicular to the motion. These two perpendicular components in 2D or three perpendicular components 3D are known as, what is the name of these components? Rectangular component, because they are perpendicular to each other. In 2D, how many rectangular components? In 2D, these many rectangular components. In 3D, one extra you have. In 3D, this is the rectangular components. In 3D, this is the rectangular component. In 2D, this is the rectangular component. Done. Bolo. Everyone got the idea? Now we will talk about rectangular components in a plane of vector. That means we'll be talking in 2D. You write rectangular components in 2D. Rectangular components in 2D. How many components will come? In rectangular components in 2D, how many rectangular components will come? 2 will come. And this is what you have studied. A cos theta, A sin theta, F cos theta, F sin theta. Because whenever we do numerical, we always talk in 2D only. So that's why you have studied like that, F cos theta, F sin theta. We will get to know. Yeah. Rectangular component in 2D, we are going to talk. Just see here how this thing will be there and how question will be asked. Just see here. Yeah. Okay, no problem. So let's take, for example, someone says, Acha, what is this board? This board is 3D or 2D? This screen is 2D or 3D? 2D, yeah. So I'm going to put one vector in 2D. You know your mobile screen, every screen is 2D only. So I will simply say, so let's take one vector in 2D. For example, let's assume I'm having vector A, which is in 2D. You can see vector A, which is in 2D right now. Okay, no problem. This is vector A. Magnitude of our vector A is A. Magnitude of vector A is A. Okay, no problem. And board is 2D, which is known to everyone. Nothing to worry. Yeah, okay, no problem. Now I'm going to break this. I'm going to split the vector into its two rectangular component. Now I will always remember, whenever you break the vector into component, now you will require one reference line. For example, assume this vector A is making some angle theta with a reference line. Assume this is the reference line. Right now I'm taking this reference line as x-axis. Not mandatory. Tomorrow this vector may make an angle theta with y-axis also. It depends line. Right now I'm saying, sir, vector A of magnitude A is making angle theta with the reference line, and my reference line is x-axis. Yeah. Okay, no problem. Yeah. Now someone asked me, break this vector into two parts. Break this vector into two parts. I will simply say, I can break very easily. I will simply say, sir, this vector will have two components. You can see this. You can think from my hand. This is the vector. I am going to break this vector into two parts. One along the reference line and one perpendicular to the reference line. This is how I'll break the vector. This is the vector. I'll break the vector into two parts. One along the reference line, one perpendicular to reference line. These are the two components. One along the reference line, one perpendicular to reference line. So along the reference line component is known as A parallel. Along the reference line component is known as A parallel. And perpendicular to reference line component is known as A perpendicular. And A parallel will be coming as, can you tell me, along the reference line component will be having how much value? If magnitude is A, angle is theta. Along the reference line, nth component will come A cos theta along the reference line. Tomorrow reference line may be y-axis also, then their y component will become A cos theta. Yeah. So along the reference line we name as A parallel. A parallel will come A cos theta. And perpendicular to reference line will come A sin theta. Okay, no problem, no problem. Yeah. And always remember, with the help of A perpendicular and A parallel, you can find magnitude of the vector also. Because these are two rectangular components, they are perpendicular to each other now. So your vector will be like hypotenuse. Your vector will be like hypotenuse. So you can find magnitude of vector also as with the help of A parallel square plus A perpendicular square. Perpendicular means perpendicular to the reference line. And it's not mandatory that angle will be always given with x-axis. It can be with y-axis also. Is it okay? Is it okay? Bolo, 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 bolo. Everything understanding which is present on the board? Okay, no problem, sir. Yeah, simple thing we are understanding, sir. No problem. Yeah. Now, sometimes they will give you A perpendicular and A parallel. For example, two rectangular components will be known and they will ask you find the angle with x-axis, or they will ask you find the angle with y-axis. You can find angle also very easily, because you'll simply say, sir, if you divide A perpendicular and A also very easily, because you'll simply say, sir, if you divide A perpendicular and A parallel, trigonometry also. It's not very nothing. It's trigonometry. If someone asks you this theta, you can write directly also. So this tan theta will come. What is the formula for tan theta? Tan theta is what? Tan theta is what? Opposite by adjacent. So opposite to it is A perpendicular. Adjacent is A parallel. So directly also you can say A perpendicular by A parallel. Yeah, opposite by adjacent. You can see tan theta will be coming as opposite. So this is the reference line. Who is opposite to reference line? A perpendicular. Adjacent, this one. So that is how also you can say opposite by adjacent. Is it okay? Is it okay? Everything present on the board is okay. So once you can see this is enough. We have got the idea. Now we can do some questions from here. So two rectangular components in 2D. If you know, come on, along the reference line component is how much? Along the reference line component is how much? Which component is along the reference line? Which component? Parallel component. What is its value? What is its value? Cos theta component. Is it mandatory that x component will be always A cos theta? Is it like that? X component? No, it depends on the reference line. Yeah. So this is how we have talked about. If you know the rectangular component, you can find magnitude with the help of A parallel square plus A perpendicular square. You can find tan theta. Come on, tell me what will be your tan theta? Tan theta, opposite by adjacent, or you can say A perpendicular by A parallel. Done. Bolo, Torga. Done. A perpendicular by A parallel. That is our tan theta, or opposite by adjacent, sir. We can get very basic thing. I'll give you one question. Let's start with one question. Easy question. First one is the gift. You write, a vector has rectangular component 5 and 12. A vector has rectangular component 5 and 12. Find its magnitude. I think everyone will get, yeah, 13 will come. Just we wanted to start. So if two rectangular components are given, you can find magnitude very easily. Under root of a perpendicular square plus a parallel square, that will give you root 169. That will be giving you 13. Easy, no problem. Yeah. Again, I will give you one easy question. You write, find x and y component of the given force. You have to tell me you have to tell me fx and fy. You have to tell me fx and fy. So fx you already know, fx will come f cos theta, fy will come f sin theta, f is given 10, so 10 cos 30 you know, root 3 by 2, so this will give you 5 root 3, fy you know, f sin theta, sin 1 by 2, so this will give you 5 Newton. Is it okay? Is it okay? Yeah, this is wrong. This is wrong. This is what I was telling you. Arey Baba, people remember x component is f cos theta y. That is wrong. Actually, 90% of time our reference line is x-axis. That's why it comes in your mind that always it will happen. But it is not happened always. Always remember it depends. Angle is given with which axis. Now angle is given with x-axis. So along the reference line, this concept is correct. A parallel will be a cos theta, a perpendicular will be a sin. This will always work. Yeah. So along the reference line, sir, along the reference line will come cos theta component. So 10 cos 30. That will give you 5 root 3. Yeah. Okay. So this is your fy. This is along y-axis because a parallel is along y-axis. So this will be reverse. And if anyone asks you, this is wrong. If anyone asks you x component, you will simply say x component is the perpendicular component, sir. So fx is our a perpendicular. A perpendicular we know, sir, a sin theta. So f sin theta, f is 10 sin theta 1 by 2. So that will be giving you 5 Newton. Is it okay? Is it okay? समझे बात क्या? They ask this type of question. Yeah. In projectile motion, they gave the angle with vertical, if you remember. This year in the NEET, they gave the angle with the vertical. Normally, you remember speed at the top, at the maximum height speed will be u cos theta. But answer was coming u sin theta because reference line they took y-axis. I think everyone got the idea. Done. I will give you one more question. Just see. Okay, no problem. Basic question. Yeah. Jayanti, what is that standard question means? Say some standard questions. What is that, Jayanti? Hey. Do one more question. You write. Say some standard question means which standard question I am not getting. Jayanti is saying, sir, say some standard question. Yeah. So Jayanti is not saying anything. Let's do one more question. Yeah, you write. Find the angle made by vector 2i cap plus 2 root 3 j cap with x-axis. Find the angle made by vector 2i cap plus 2 root 3 j cap with x-axis. So you can do with the help of both ways, with the help of tan theta you can do, or directly also you can do opposite by adjacent. Yeah. Yeah, these are the NEET level questions. What do you think? These are the NEET level question. Yeah, so 2i cap plus 2 root 3 j cap, and you must know the basic thing. Yeah, if you would have known, you would have got selected last year only. Okay, no problem. Yeah. So 2i cap plus 2 root 3 j cap. So they are asking you find the angle with the x-axis. We can find very easily, no problem. Both ways you can do. One way is with the help of A parallel and A perpendicular. So here they're asking you with the x-axis. If they're asking you find the angle with the x-axis, that means your reference line will be which axis? If you want to find the angle with the x-axis, what is your reference line? What is your reference line? Reference line is your x-axis. Yeah, with x-axis they're asking you, that means your reference line is x-axis. If your reference line is x-axis, that means x component. What is the meaning of reference line? Reference line is x-axis, means your x component will be your parallel one. And your y component will be perpendicular one. Yeah, A perpendicular. And from here you can see which is along x, which is along y. So A parallel you can see. So reference line, if it is said reference line is x-axis, find the angle with x-axis, means x-axis is the reference line. If x-axis is the reference line, A parallel will be x component. And that is given here 2. And A perpendicular is other component, that is given as 2 root 3. So if you want to follow like this, then you have to use that formula. Tan theta will come A perpendicular by A parallel. That will be coming as 2 root 3 by 2. That will give you root 3. That will give you theta as 60 degree. This is what everyone has got. Okay, no problem. This is with the help of entire process. But don't do like this. This will be lengthy and you will be confused also. What is A parallel? What is A perpendicular? Better way to do is with the help of, you already know. Sir, what is given x? How much x given? 2, sir. How much y given, sir? 2 root 3. And they're asking you angle with what? They're asking you angle with x-axis. So let's assume this angle to be theta. Now you can find tan theta directly. This is the actual way which you should use. Opposite by adjacent, 2 root 3 by 2. So from here you also will get 60. Which is more better? First method or second method? Second one. So follow like this. This will give you answer more fastly and without any doubt. Here once you draw the diagram, now everything appear to you. Oh, this is opposite by adjacent, we can get very easily. Do the next question, come on. Do one more question. You write. A vector 3i cap plus 4j cap. A vector 3i cap plus 4j cap is rotated. Little thinking you have to put now. A vector 3i cap plus 4j cap is rotated 37 degree. A vector 3i cap plus 4j cap is rotated 37 degree in anti-clock. Trishal, very good. A vector 3i cap plus 4j cap is rotated 37 degree in anti-clock. Find the new vector obtained. You know, if you rotate the vector, direction of the vector will change. So vector will change. So that's why they're asking you find the new vector. Trishal, very good. Sai, very good. 1920, wrong. You have to find new vector. Find new vector obtained. You have rotated the vector now, so vector will change. Lisha, wrong. Gayatri, correct. 1 plus half, wrong. Wrong. Suhas, wrong. Priyanka, correct. Okay, see here, no problem. Do this question. I will once tell, because first time, if you are doing for the first time, you feel little difficulty. But after this, I will give you next question. That question you must be able to do. Easy. Achha, you tell me, yeah. This is the vector. This is the vector. Achha, tell me, if you rotate the vector, vector will change. If you rotate a vector, does vector will change? If you rotate a vector, does vector will change? Tell me answer for this. Of course, vector will change, Baba. Vector, Priyanka is saying no. So yes, vector will. This is the vector you see. This vector is right now pointing upward. If I rotate by 90 degree, it will point towards me. So always remember, whenever vector is rotated, now vector changes. But one thing do not change is related with the vector. Can you tell me what is that one thing? What is that one thing? Magnitude. This pen, if I rotate 100 times also now, its direction will keep on changing. But if you look at length of the pen, it will remain fixed. If my hand is a vector, if I rotate for 10 days also my hand, length of my hand will not change. So always remember, whenever vector is rotated, direction changes. That's why vector changes, but magnitude remains unchanged. So in all this situation, whenever such question is asked, you think that direction, magnitude will not change. But in order to write final vector, you must know what is the position of initial vector. Initially, how the vector was appearing, sir. First, you have to see that. And for that, you'll simply say, sir, this is our x-axis, this is our y-axis. And our vector is like this. How much is along x? How much is along x? How much is along x? Our vector is having how much along x? Along x it is having 3. Along y, how much it is having right now? 4. So what is the angle already, sir? Already angle you can find. Already tan theta you can find. Tan theta will come opposite by adjacent. That is 4 by 3. Means theta is already 53 degree. Everyone knows now. Tan 37 3 by 4. Tan 53 4 by 3. सबको पता है? This is already given in the question. You have not done. You have just put that question in the form of diagram. Now question starts from here. Achha, if this is 3, this is 4. What is the length of your vector? What is the length of vector? If this is 3 and 4, what is the length of your vector? What is the length? Length is 5. Under root of 3 square plus 4 square, that is 5. Now from here, this angle is already 53. Now from here, you have to check in which sense vector is rotated. Everything will count. Now from here, you can rotate your vector in 2 ways. One way clockwise, other way anti-clockwise. One way clockwise, other way anti-clockwise. Now in the question, they are saying your vector is rotated by 37 degree anti-clock. Means you are rotating like this. By how much you are rotating? 37. So what is the total? Already 53 undi, extra 37. So enter total angle, mottam angle will become 53 plus 37 with x-axis, that will become 90 degree. You tell me who lies at 90 degree with your x-axis? Who lies at 90 degree with your x-axis? Y-axis. That means your vector will jump on y-axis. This is how your vector will now appear. This is the bold arrow which I am showing there. This is how your new vector will appear, whose magnitude is how much? 5. Direction is along y-axis. So 5 along y-axis means 5j cap. This is our A dash vector. Samjhe kya? Everyone understood the process? Find initial angle, add the new angle or subtract depending on the situation, you will get the answer. Surya, how 5? Surya abhi aaya kya? Just now born Surya. Surya 3 akada, 4 akada, so akada 5 na baba. Ha. Good afternoon, sir. Sir, class is started. Now class started, I think 15 minutes, half an hour back. Lisha. Pythagoras theorem, baba, rectangular component 3 and 4 magnitude will. Done. Bolo, bolo. Can I give you next question? Shall I give you next question? And this is not any question, this is a process. You have to understand the process. And this time, I want correct answer from everyone without anyone giving wrong answer. You write? If the vector 3i cap plus 3 root 3j cap. If the vector 3i cap plus 3 root 3j cap is rotated, if the vector 3i cap plus 3 root 3j cap is rotated 60-degree clockwise. 60-degree clockwise. Trishal, very good. 60-degree clockwise. Find new vector. Rishi, very good. Find new vector. Always remember, magnitude will not change. First calculate the magnitude, then think. Suhas, very good now. Last time given wrong answer, this time given correct answer. Very good. Learned how to find new vector. Shreya, tell me the answer. Sojanya, very good. Neha, very good. Shreya is saying 0. How 0, Baba? Vector magnitude is 6. Magnitude is 6. I think from Shreya, someone is asking how many chapati you had in the morning. She's saying 0. Priyanka, very good. Yeah, I think everyone will get. Everyone will get. Lasha, very good. Lasha came late, but saying correct answer. Yeah. 6 I cap. Answer will come 6 I cap. Del, very good. 2 1 2 1, very good. So first thing always remember, sir, you are rotating. Rotate for 10 days also. Gayatri, very good. Rotate for 10 days also, sir. Good. 2 1 2 1, very good. So first thing always remember, sir, you are rotating. Rotate for 10 days also. Gayatri, very good. Rotate for 10 days also, sir. But one thing I know, magnitude of the vector will not change. Magnitude I can find directly from here also. That will come, sir, under root of 3 square plus 3 root 3 square. That is giving us root 36. That will is giving you 6. Okay, no, but this is what magnitude. If you feel problem, you can do from here also, no problem, sir. Sir, I will take my x-axis like this. These are y-axis, sir. Vector akkada undi. Vector akkada undi. Sir, enta vector undi akkada. So, akkada component, x component 3 undi. This. These are y-axis, sir. Vector akkada undi. Vector akkada undi. Sir, enta vector undi akkada. So, akkada component, x component 3 undi. Y component 3 root 3 undi. Okay, no problem. Akkada angle enta undi, sir. So, magnitude will come under Pythagoras theorem. Under root of this square plus this square, that is 6, sir. Enta root 3 undi. Okay, no problem. Akkada angle enta undi, sir. So magnitude will come under Pythagoras theorem. Under root of this square plus this square, that is 6, sir. Enta angle undi, sir. Tan theta. Nenu ledu. So calculate chayandi. So opposite by adjacent. So that will give us a root 3. So theta 60 degree undi. Now 60 degree theta. You tell me if you now you can rotate your vector in two different matter. You can rotate anti-clock also, clock also. But in the question they are saying you vector is rotated clockwise. You tell me already angle 60. If you rotate further by 60 degree, where your vector will jump? Come on, tell me where your vector will go. Already 60 extra 60. You are again rotating clockwise. So vector will come on x-axis. So once vector will come on x-axis, length will not change. So this is the new vector that will be formed. So 6 I cap, this is our A dash vector. Can I be 100% sure such question will do without any doubt? Rotation of vector, angle with x-axis, angle with y-axis, component along reference line, perpendicular to reference lines. अरे हो जाएगा. One more. What is one more? Yeah, you can do it. It's easy. Come on. Achha, it's the same question if I ask you. If the vector is rotated 30 degree anti-clock, you can see at the last become very easy. I will share. You can see. Then it will 30 degree anti-clock. So it will become 6j cap. 30 degree anti-clock, it will become 6j cap. It will go to y-axis. Yeah. I'm giving you time of 5 seconds. See all this situation. We'll move further. Aage badhenge. Come on. These are the basic things of rectangular component and they are not generally asked directly. Use of these will come in different chapter. Different chapter use will come. For example, projectile motion use came in last this year only in the NEET. Once you complete, you can say done, sir. Okay, very good, very good, very good, very good. Yeah, yeah. Now we will talk about rectangular components in 3D. And rectangular components in 3D we study with the help of direction cosine. Rectangular components in 3D will come three. X component will also come, Y component will also come, Z component will also come. And we study this with the help of direction cosine. You can write direction cosine. You can write direction cosine. Direction cosine. And in bracket you can write 3D. Means in space we will talk. If a vector is in space, how to get its component, how to find its direction cosine. Shall we start? Shuru kare? Shall we start? Direction cosine. Okay, okay, no problem. Not very important topic. It's not like that. Direction cosine. Okay, okay, no problem. Not very important topic. It's not like that every time, every year question. Till now, no question has been asked from direction cosine. But somewhere in NCERT, they have time every year question. Till now, no question has been asked from direction cosine. But somewhere in NCERT, they have mentioned these words. So that's why we are studying. That's why we are studying. So just see, I mentioned these words. So that's why we are studying. That's why we are studying. So just see, yeah, okay, we are going to move further. Yeah, okay, just see here. Okay, Acha, you tell me what is the meaning of direction cosine? What is meaning of cosine? What is meaning of cosine? Cos theta. Full form of cos theta is cosine theta. We write in short. You always write na cos theta, cos 30, cos 60, cos 40, cos 45. Actually, they are cosine 60, cosine 30, cosine 90. So always remember, here we are going to get help of cos theta. Definitely, sir. Name is direction cosine. In direction cosine, name only cosine is there. That means cos theta is there. But you will simply say, sir, we find cos of angle now. How you can find cos of direction? Is it possible to find cos of direction? But you will simply say, sir, we find cos of angle now. How you can find cos of direction? Is it possible to find cos of direction? Cos of east, cos of west, cos of south? What do you think? Okay, just see it. Here also we will find cos of angle only. But always remember, angle also gives you idea about direction now. Angle also give now. You can say now this fruit is located at the angle of 30 degree from me. So always remember, direction can be also obtained with the help of angle. Here direction is telling you about angle, and cosine is telling you about cos theta. Are you getting this? Theta we are going to talk. Bolo. Idea mila kya? What is the meaning of direction cosine? No need to write. I'm just giving you meaning of direction cosine. Chamka kya? Well again the meaning of direction cosine. Well again the cosine means cos theta. Sir, how will find cos theta of direction? Direction is also told with the help of angle. So that direction means angle. Cosine means cos theta. So we are going to find cos theta of the angle. Cos theta of the angle. Angle made by whom? Angle made by whom? Who will make the angle? Who will make the angle? Come on, tell me. Who will be fast? Who will make the angle? 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 Bolo jaldi. Who will make the angle? What happened? Vector will make the angle. Vector will make the angle, and that vector will make angle with x-axis also, y-axis also, z-axis also, and those angles are known as alpha, beta, and gamma. Now just see here how we will talk. Just see, AKD sir will make the angle. Wow, nice. Okay, now just see here. So this is how things will happen. Assume we are having our all three axes. All three axes are here, sir. This is our x-axis, this is our y-axis, this is our z-axis, and our vector A is there, and our vector A is there. This is the vector A we are talking about. This is the vector A. Since it is in 3D, you can write it will have all three components: X I cap, AY J cap, AZ K cap. Okay, no problem. Your vector A will have some magnitude also. You know the magnitude. How to find under root this square, this square, this square. So under root of X square plus AY square plus AZ square. Okay, no problem. So you can see this is in 3D. All three axes are there. You are having a vector A, which is of course X I cap, AY J cap, AZ K cap, and it is having your magnitude under root of X square plus AY square plus AZ square. And your vector will make some angle with all the three axes. With X axis angle we name as reference as alpha. Conventionally we take angle with X axis we take as alpha. Angle with Y axis we take as beta, and angle with Z axis we take as gamma. And tomorrow when you'll find cos of this alpha, that is one direction cosine. Tomorrow if you find cos of this beta, that will be one direction cosine. Tomorrow if you form cos of this gamma, that will be one direction cosine. First you can draw this. Then we will talk how to find cos alpha, cos beta and cos gamma. This is not Lami's theorem, Baba. This is direction cosine, Baba. Kiran, what you are asking? Is that, sir? Lami's theorem is that, sir? Lami's theorem is there. We'll study Lami's theorem also. Don't worry. We have to study just basic part of Lami's theorem. Is it okay up to this? Is it okay? Up to this, is it okay? Up to this, is it okay? So just see once again. Yeah. Okay, no problem. So you are having a vector in 3D. Sir, vector will make some angle with x-axis, that is alpha. Vector will make some angle with y-axis, that is beta. Vector will make some angle with z-axis, that is gamma. Sir, these angles also tells us direction. So tomorrow if you find cos of these angles now, that is known as direction cosine. Cos alpha, cos beta and cos gamma, and see how to calculate. This cos alpha, cos beta and cos gamma. Just see here, yeah. And I will ask you, you can calculate. It's not needed for me to tell. Just see here. I will ask you some question. If you are able to tell the answer, that means you'll be able to calculate direction cosine. Just see here, yeah. You tell me, what is the component along the reference line? Which component of a vector is along the reference line? What is that? Cos theta component, not y component, Baba. Cos theta, A parallel A cos theta. So along the reference line component is cos theta component. Yeah. Okay, no problem. Tell me this vector, how much angle this vector is making with x-axis? If I take reference line is the x-axis, what will be its reference line at x-axis? How much angle it is making with x-axis? Alpha. It is making an angle alpha with the x-axis, sir. If reference line is x-axis, it is making an angle alpha with the x-axis. So what will be its component along the reference line x-axis? Can you tell me? A cos alpha. Of course, sir, I know along the reference line component is cos alpha component. So if it is making alpha with x-axis, so along x-axis component will be A cos alpha. What is that value? X. You see, what is your component along x-axis? X. So A cos alpha will be X. Similarly, if you take reference line as y-axis, what will be the angle? If you take reference line along y-axis, what will be angle? Beta. So what will be the component along the reference line? A cos beta. A cos beta. That will be how much? Y component. What is that? AY. Similarly, sir, with z-axis, A cos gamma, sir. What will be that component? AZ. That means, sir, from here we can find cos alpha, cos beta and cos gamma. Cos alpha will come, sir, AX by A. Cos beta will come, sir, AY by A. Sir, cos gamma will come, sir, AZ by A, AZ by A. And these cos alpha, cos beta and cos gamma, these are known as direction cosines. These are known as direction cosines. These are known as direction cosines of the vector. AX by A, AY by A, AZ by A. What is A here? 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 What is A? Magnitude, which you know now, under root of x square plus ay square plus az square. So very easy to find direction cosine. You can find direction cosine very easily because x will be given, a you can find x by a, ay by a, az by a. Come on, tell me. Cos alpha will be equal to direction cosine. Cos alpha will be equal to cos alpha equal to x by cos alpha, baba, x by a, cos alpha x by a, cos alpha. If you cannot type, you have to speak. Cos alpha x by a, cos beta ay by a, cos gamma, bolo cos gamma, cos gamma, az by a, az by a, az by a. Yeah. Cos alpha x by a, cos beta ay by a, cos gamma az by a. Okay, no problem, no problem. Yeah, okay, easy, sir, easy. Yeah, okay, huh? Once you complete writing, you can say done, sir. Yeah, okay, very good. So first question which is asked, they will give you a vector and they will ask you find direction. Cosine means you have to find cos alpha, cos beta and cos gamma. Now see the second question which is asked from here. And this result is going to be very, very important. Very, very important. Question is also asked. I think some of you are knowing also. They will ask you, if we square all these direction cosines, cos square alpha, cos square beta, cos square gamma, and if I add them, then answer will come okati. Answer will come 1. Yeah, okay. So if you square and add, you will get cos square alpha plus cos square beta plus cos square gamma. This value will be coming as 1. Yeah, this value will be coming as 1. So if anyone asks you to find cos square alpha plus cos square beta, yeah, Kiran, very good. So cos, if you square, you can prove also. You can prove also. You can just substitute. You will find that 1 or everything will get cancelled. It will come 1. So cos square alpha plus cos square beta plus cos square gamma will be equal to 1. And same result you can write in the terms of sine also. If you write, by without squaring, you will not get baba. It is cos square alpha plus cos square beta plus cos square gamma will be 1. Yeah, okay, very good. And everyone is knowing about sine also. If you want, you can write in the terms of sine also. If you write in the terms of sine also, then it will come sine square alpha plus sine square beta plus sine square gamma. That will come equal to 2. So these two are very, very important results. They are actually asked in your NEET. If they have to ask you, they will ask you this thing. They will say you, if a vector makes an angle alpha, beta and gamma with x-axis, y-axis and z-axis respectively, then what will be value of cos square alpha plus cos square beta plus cos square gamma? That will be equal to okati, 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 1 cup tea, okati. Sin square alpha plus sin square beta plus sin square gamma will come rendu, 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 rendu. Do one question. If you want, you can prove also. Shall I tell you how it is coming? Or you'll be able to remember? It's your choice. I will tell in one line. It's not, it's very easy. One line we can derive. No problem, yeah. But keep in your mind. Sine one also I will tell. Nothing to worry. Just see. I will tell in one line. Just see. You can remember. Of course, you have to remember. In exam, you are not going to derive. It's impossible to derive. You have only 1 minute. You have to remember the famous results. Yeah. I'll simply say, what's so big deal? Square and add. See here what will happen. If you square and add, for example, someone says, okay, sir, I will find cos square alpha plus cos square beta plus cos square gamma. Sir, square them and add. So when you square, this will become ax square by a square plus ay square by a square plus az square by a square. You can see this is what will happen when you square and add. Now from here, you can take 1 by a square common. This will become ax square plus ay square plus az square. And this is square of magnitude also now. This is also a square only na baba. This is what you have written. A magnitude is under root of this. So this will give you how much? This is actually, sir, a square only. So this will get cancelled. So that's why you'll get 1. That's why you'll get 1. चमका क्या? वेलगेंदी फाइनल? Okay, very good. Yeah, easy. We can square and add. Yeah. Now someone said, okay, sir, cos we understood, sir, but how you wrote for sine? You can always convert cos to sine, Baba. You have studied in class 2, 3. You know, cos square theta will come 1 minus sine square theta. You know now 1 plus cos square theta plus sine square theta is 1. So cos square theta you want to convert into sine now. So you can write cos square theta as 1 minus sine square theta. So here it will come 1 minus sine square alpha. Here it will come 1 minus sine square beta. And here it will come 1 minus sine square gamma. That is equal to how much? 1. In place of cos, I am putting sine. Now from here you can see, okay, no problem. What will happen? 1 you can cancel. How many ones are left here? Remaining minus you can send that side. So minus sine square alpha will become plus sine square alpha. This will become sine square alpha plus sine square beta plus sine square gamma. And here what is left? 1 plus 1, 2 is left. So that's why we are getting 2. Done. Bolo. Final I'm asking. We'll move further. Aage badhenge. We'll do some questions. It's better to remember. Lisa, that is what I said. You have to remember. Okay. So come on, final. You tell me what is cos square alpha plus cos square beta plus cos square gamma will be equal to okati 1. Acha sin square alpha plus sin square beta plus sin square gamma will be equal to sin square alpha plus sin square beta plus sin square gamma will be equal to 2. Will be equal to 2. Now do one question. Come on. You write. Find the direction cosine of the given vector 3i cap, 2i cap plus 3j cap plus 4k cap. Find the direction cosine of the given vector 2i cap plus 3j cap plus 4k cap. Direction cosine means cos alpha, cos beta, cos gamma. So cos alpha ax by a. But we need to find a, sir. So first we'll find a. Then we can do very easily. A is coming root 29. Yeah. Then 2 by root 29, 3 by root 29, 4 by root 29. Answer. Priyanka, very good. Rishika, very good. Vikram Code, very good. Sojanya, very good. I will simply say, sir, for finding direction cosine, first requirement is find A. A will come under root of 2 square plus 3 square plus 4 square. So that will come as, sir, root 29. This is the value of A. Then once you know, yeah, Narendra Reddy, very good. Yeah, Priyanka, very good. Kiran, very good. You can give answer. I am waiting, no problem. Kiran, very good. If you want, you can show your copy also if tough to type. Nayak is saying, got it, sir. Wow. Kiran, yeah. I think everyone will get. What's so big deal, sir? What's so big deal? Yeah. So, ax by a. Sir, you want direction cosine means you want cos alpha. Cos alpha will come, sir, ax. This is the x component. Ax by a. 2 by root 29. Cos beta will come ay by a. 3 by root 29. Cos gamma will come 4 by root 29. And one more thing I will tell you. That will not be required, but okay. Somewhere, these direction cosines are also represented by L, M, and N. We also represent direction cosines with L, M, and N. Every time saying cos alpha, cos beta, cos gamma becomes lengthy, so people simply say L, M, N. Lemon. Yeah, you can remember with the help of lemon. But no, this is not required. This is not required. Not given as per our NCERT, but okay. I said you just for knowledge. Done. Do the next question. Come on, do the next question. Agla question karo, come on. Do the next question. You write. A vector makes equal angle. A vector makes equal angle with all the three axes. A vector makes equal angle with all the three axes. Find that angle. A vector makes equal angle with all the three axes. Find that angle. Trishal, very good. Suhas, wrong. Rohita, very good. Del, wrong. Think. It is not in 2D. Don't think, sir, 120, 120, 120. No, it's not 2D. It's not 60, 60, 60. No, it's 3D. Kiran, wrong. Saujanya, correct. You have to take help of cos square alpha plus cos square beta plus cos square gamma equal to 1. That is the use. You cannot take 90, 90, 90. It's 3D, Baba. 30 degree. Cos inverse 1 by root 3 will come. Priyanka has said correctly. Tina has said correctly. Thoda socho. It's in 3D. So the thing that you studied will not work now. This is the use of this result, cos square alpha plus cos square beta plus cos square gamma. Come on, everyone, do tell me the answer. I'm waiting for the answer. Nayak, very good. Finally, everyone has got. Yeah, okay, very good, very good. I'll say, sir, what's so big deal? Okay, it is in 3D now, so we cannot think 120 will make 360. We cannot think like this. We'll simply say, sir, what you are saying? You are saying, sir, all the angles are equal. That means alpha is same as beta, is same as gamma. And we know, huh? Yeah, iPhone, you can do that, no problem. Yeah. No, right now you can join the classes in the Zoom only. In the Zoom only we are having our YouTube live session. In few days we will shift to the app. Yeah. So all angles are equal means alpha is equal to beta equal to gamma. And you already know cos square alpha plus cos square beta. Beta is also equal to alpha. So you can assume to be alpha plus cos square gamma. Gamma is also equal to alpha. So cos square alpha will be equal to 1. So from here you can get 3 cos square alpha equal to 1. That means cos square alpha will come 1 by 3. So cos alpha will come 1 by root 3. So alpha will come cos inverse 1 by root 3. So alpha will come cos inverse 1 by. Is it okay? Is it okay? Is it okay? Ho gaya kya? Everyone got? Is it okay? Easy na? Yeah. So direction cosine, I think it is easy for you. I'm giving you time of 5 seconds. See all this situation. We'll move further. And I will tell you one interesting story. You like stories, na? Hungry, sir. Yeah, hungry for knowledge. Yeah, people are saying, sir, hungry, sir, but hungry, I know that hunger is for knowledge. And I will not tell you any story, means I will tell you a fact, which you must be knowing, I think, you know, okay. But still I will tell. It's my duty every year. I make people aware. I make all my students aware of the things going around them. So in the same manner, this year also I will tell to just to make you aware. Yeah. Yeah. Suhas is saying correct. Sun rises in the east. And if you put your leg on banana peels, you will fall. That is also correct. Suhas is saying one fact I know, sir. Sun rises in the east. Wow. Okay, no problem. Shall we talk about that? One fact. Shall I tell you one fact? After knowing that fact, really you will feel proud of yourself. Really you will feel proud of yourself. You are not knowing. That's why you treat yourself as normal people. After I will tell you, will feel proud. Yes, that feeling will come. Acha, you know, one theorem we study here. What is that theorem? What is that theorem? The theorem that we study. That is the mistake. Only Pythagoras. So go to class 2. Priyanka is knowing. Yeah. Always remember the theorem that you see na, Lami's theorem. That is its incomplete name. It is complete. It's incomplete. It's not Lami's theorem. The people of US, Western people are making us hide our reality. Our world they are hiding. Actually, it's not Lami's theorem. Lamy seems to be a foreigner, but actually it is not Lami's theorem. It is Lakshmi's theorem. This is Indian. This theorem was discovered by Indian. Western people always wants to take the credit. That's why they have written that as Lami's theorem. But actually it is Indian theorem. Angle came cos inverse 1 by root 3. Are you knowing that? And it's Lakshmi's theorem. You should be happy because, yeah, in entire physics, we have only two lady scientists. What are those two lady scientists? Who are those two lady scientists? Don't say Curie, give respect. Madam Curie. One is Madam Curie and one is Madam Lakshmi. These are the two lady scientists we have. One is Divya Madam. Divya Madam is in chemistry. Yeah, okay. Okay. It's Nayak. Check on Google. Yeah, you are at the home. Yeah, and I will tell why I was saying you will feel proud of it. First thing, Lakshmi is lady and she is Indian. That's why we should feel proud. But there is more. Yeah, not Lakshmi, Madam Lakshmi. But there are more things to feel proud. This Madam Lakshmi was born. Why I'm saying you should be proud? Because this Madam Lakshmi was born in Andhra Pradesh only. In our AP only she was born. You know that? You know that? She was born in AP only. At that time, AP and Telangana both were combined. She was born in AP only. And do you know that? How you know? I know because it is in Google. Lisha, you after class you can Google it. It will come, Baba. Everything is there on Wikipedia. So Lakshmi was born in Andhra Pradesh, and that too, in Krishna district. Why I feel so much of proud living in Krishna district? She's Telugu girl. Yeah, she's Telugu girl. She was born in AP in Krishna district, and that too, a theorem I will tell, that too in Vijayawada. That too in Vijayawada. That's why I feel every day I feel proud that I live in the place of Madam Lakshmi. Still not living, passed away. Yeah, and she did not study in Gosala. Sir, house is near our campus. Yeah, girls campus pakana Gangur biryani undi na. Gangur biryani pakana one house undi. House Lopla board. Theorem I will tell. You have to wait for the theorem. Yeah. You see, some people are searching on Google also. Suhas, thank you. I made someone to believe that actually such theorem exists. People started searching. That is the thing. That is what I wanted. That is what I wanted. I wanted to make some people believe that is a true story. People started searching. Sir, complete name is Bernard Lamy. Okay, no problem. Yeah, we'll move towards this Lamy's theorem. Okay, so discovered by Indian, but they thought good name will be Lamy's. So that's why we give name as Lamy's theorem. Okay, आगे बढ़े क्या? Shall we start with the theorem? Okay, just see here. Today we will just talk about meaning of Lamy's theorem and basic application. What is its meaning? Next class we'll do more questions from here. Yeah, okay, just see here. Okay. Always remember, Lamy's theorem will be applicable when three forces will act on the body. Not more than three, not less than three. When three forces act on a body, then only you can apply Lamy's theorem. And second condition is also there. Body must be in equilibrium. Actually, Lamy's theorem is a theorem which deal with a body under equilibrium under the action of three forces. Three forces acting on the body and body is in equilibrium, then we can apply Lamy's theorem. One formula will come. You write this point. You write. When three forces are acting on a body, when three forces are acting on a body, when three forces are acting on a body and body is in equilibrium, when three forces are acting on a body and body is in equilibrium, when three forces are acting on a body and body is in equilibrium, then by Lamy's theorem, if three forces are acting on a body and body is in equilibrium, then by Lamy's theorem, we can say that then by Lami's theorem we can say that, F1, first force I am assuming as F1. Then by Lami's theorem, then by Lami's theorem we can say that F1 by sine theta 1 will be equal to F2 by sine theta 2 will be equal to F3 by sine theta 3. This is your Lami's theorem. These three forces will be related with each other like this. F1 by sine theta 1, okay, it will be equal to F2 by sine theta 2 will be equal to F3 by sine theta 3. This is our Lami's theorem. Is it okay? So if three forces are acting, if three forces are acting on a body, body is in equilibrium, then by Lami's theorem, F1 by sine theta 1 will be equal to F2 by sine theta 2 will be equal to F3 by sine theta 3. But in your mind, it will be coming, sir, which angle is theta 1? Does any angle will be theta 1? Does any angle will be theta 2? Does any angle will be theta 3? No, it's not restaurant that you'll go and you'll order anything. There is a pattern to write this theta 1, theta 2, theta 3. Can anyone tell me? Bikram has said, correct. Which angle will be theta 1? Which angle will be theta 2? Which angle will be theta 3? Priyanka, very good. Always remember, always remember, this is the way to take the angle. Just see here. I will show you with the help of one diagram. Opposite to the force. Very good. Many people are knowing. Just see here. I will show you with the help of diagram that will give you clarity about this angle. That will give you clarity about the angle. Just see here. For example, just see. Assume I am having one body here. This is the body. On this body, assume three forces are acting. I am naming this force as F1. Anyone you can take F1, anyone you can take F2, anyone you can take F3. Let's assume this force is F1. Another force is acting. Let's assume this force is F2. Let's assume another force is acting. Let's assume this force as F3. Now, these forces will be always known to you. Angle you have to search by yourself. Which angle is theta 1, which angle is theta 2. So always remember, if you are taking this force as F1 now, okay, iPhone, I will talk. After the class. If this force is F1, if this force is F1, then always remember any angle is not theta 1. Theta must be opposite to the angle which you are talking there. If this force is F1 now, so you have to see the angle opposite to F1. Angle opposite to F1 will be this one. So this angle is your theta 1. This angle is your theta 1. Similarly, if you take this force as F2, if you take this force as F2, angle opposite to it will be your theta 2. F2, angle opposite to it will be your theta 2. If you take this force as F3, if this is F3, you have to go opposite to the force in order to get the angle. If this is F3, you have to go opposite to F3. This will be your theta 3. So once you know this, so always remember theta must be opposite angle of the force. And once you know this, then you can write F1 by sine theta 1 equal to F2 by sine theta 2 will be equal to F3 by sine theta 3. Is it okay? Everyone understood what is the meaning of theta 1, theta 2, theta 3? What is the meaning of theta 1, theta 2, theta 3? Everyone understood? Samjhe kya? Okay, very good. So theta 1 is the angle opposite to F1, theta 2 is the angle opposite to F2, theta 3 is the angle opposite to theta 3. I will give you one question. Let's check whether you are able to see this opposite or not. Let's see. Okay. I will give you one question. Just, I am giving you forces as PQR. Okay, angle opposite to P is beta, to R is alpha, and to Q is gamma. Right, Lami's theorem. When you take force P, which angle you will take? When you take force P, which angle you will take? Just tell me. P by B. P will correspond to beta. Q will correspond to Q will correspond to Q will correspond to Q will correspond to gamma. R will correspond to alpha. Yeah. So we'll simply say, sir, P by angle opposite to it. Force is going like this, angle will be opposite to it. So angle opposite to it is beta. So sine beta. Sir, Q is going like this, Q is going like this, so angle opposite to it gamma. So everyone got how to take alpha, beta, gamma? Everyone got? Everyone got? Yeah, okay, very good, very good, very good. Yeah, very good, very good. Yeah. Now some more applications will be there that we will do in our next class. Is it okay? Syllabus is up to here. Syllabus is up to meaning basic applications of equilibrium. If it is not equilibrium, then you cannot. Okay, I will check now. Everything I will check whether request accepted or not. Everything I will check. Don't worry. So syllabus is from starting of vector up to Lami's theorem. Up to Lami's theorem, basic of Lami's theorem. Numerical we will do in next class. Any other pida samasya? Okay, bye. Bye. Study well. Feel your responsibility at home. Tata. Bye. 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 Sir, please give information. Every day class is happening. You can check. Yeah. Gym is more than enough. Gym is more than enough. Weekend exam. If you have any such problem, you can message me to me also. No problem. If you have any such problem, means exam you are not finding where is the exam, when is the exam, you can message me. I will also give you information, or I will send you at least the number where you can. I'll give my number. You can scan it. Now I'll give my number. No problem. You can message better. Calling will not work. Messaging will work. If you're not added instantaneously, it will not work, but in some time I will do. Not added in the group, or group is not there right now, not added in the app. You can message me, sir. Yeah, and with that number only you can message. I will say. Is it okay? Done? When is the test? That also I will tell. Okay, so this is how we have talked about. More situations we'll be talking in our next class. For today, we'll be ending our class here only. What target, Suhas? Bye bye, tata, bye bye. Take care, study well. Bye. Bye 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 bye. Bye. 720 target. Very good. It is in the app, Vikram.